Here we're given the function f of x equals the square root of x plus 1 minus 1 over x. We're asked to find the domain of this function. It's easy to see that this function comes in two parts, the first square root and then the rational function 1 over x. So it's going to be an interesting thing to find the domain of the entire function. The domain of the entire function f is simply the set of values that are in the domain of the first part of the function, the square root of x plus 1, which are simultaneously at the same time in the domain of the other part, 1 over x. Now, when you're looking for values of x that live simultaneously in both sets, you're looking for the intersection of each set. So the domain of the first part, the square root of x plus 1, will be intersected with the domain of the second part, 1 over x. For the square root of x plus 1, since it's an even index root, we require that the radicand, the stuff under the radical sign, be greater than or equal to 0. It can't be negative. Solve for x, we get x greater than or equal to negative 1. For the 1 over x function, the only requirement is that the denominator x cannot be equal to 0. So those are the two domains, and we're going to intersect them together by graphing them. First, we'll graph x is greater than or equal to negative 1. And we're going to intersect that with x is not equal to 0, everything but 0. And together that will form the domain of the function. So the domain of the first part intersected with the domain of the second will give us the domain of the function. Line up the negative 1s and line up the 0s on all three number lines. Now we're going to graph x is greater than or equal to negative 1. It includes negative 1 because of the equal portion, so we shade everything greater than negative 1, and then we put a boxy bracket to include negative 1. Now for x not equal to 0, we have to include everything but 0, so we put open brackets on both sides of 0 and shade everything else. Now for the intersection, we have to consider each of the regions. Now think about this. In the region to the left of negative 1, we have shading only in one of the sets. So the elements left of negative 1 will not be included in the intersection. But in the region of x values between negative 1 and 0, we are including those values in both the first set and the second set. That is what puts it in the intersection. So for the last number line, you're going to shade all the values between negative 1 and 0. And then from 0 to infinity, we have shading on both sets, so we're going to shade that. But what about the actual values negative 1 and 0? Well, negative 1 will be included because in the top number line in the first set, it's included with the boxy bracket. It is also included in the second number line as it shades directly through the negative 1. Therefore, the value x equals negative 1 is included in both sets, so it's in the intersection. So put a boxy bracket on negative 1. But that 0 is problematic because even though the first set shades right through 0 and includes 0, the second set avoids 0. It's everything but 0. So x equals 0 does not live simultaneously in both sets, so it cannot be in the intersection. So we put the round brackets on both sides of 0 and shade everything on the right. Okay, so how do we express this shading? Well, first let's express the first interval with a boxy bracket. It's everything from negative 1 comma to 0 with an open bracket. And then we union that together with open bracket, everything from 0 to positive infinity, open bracket.